In the previous videos, I was mostly concerned about this part, where we connected GAMS and Excel to feed GAMS with input data from Excel. But now we want to have a look at this part, where Matlab and GAMS interact. And the idea is not only to send the run command from Matlab to GAMS, but this arrow here, control, also contains a parameter with a value. And we can choose any parameter within GAMS to be substituted with the value in this arrow. And then we can execute GAMS and run our model, report the data back to Matlab, store whichever parameters, variables we find interesting, and then maybe send a slightly different value, and the same parameter will be substituted with this new value. And if we do this 10, 20 or 100 times, we get something like a sensitivity analysis. The data is stored in Matlab and we can plot it or report it or whatever. As an example, I did that in my thesis. The efficiency of an absorption chiller went up in steps of probably 0.5 in all these charts. And we can see here that the optimal number of absorption chillers switches from 0 to 1 at an efficiency of about 6 in this example. So we can find the turning point by running many optimizations. What we therefore need to know is how to write a GDX file with Matlab so we can send it over to GAMS. And the report from GAMS will also come in the form of a GDX file, so we need to know how to read a GDX file with Matlab. As an example, we can take this Excel sheet and we have some parameters also here and here that we want to read in, and we have the GAMS code, and that declares the sets and the parameters. We have the task file that will make sure that we read out the data from the Excel sheet for these sets and parameters, which happens by this line. We open the GDX file, read out the data, close it, and then we would like to substitute, for example, one value, the project duration, with a value that is given by the GDX file from Matlab. That could be substituted and with the element subst1. So now we need to write a GDX file with Matlab that contains a parameter substitute, and it has an element subst1, and that element needs to have a value assigned to it. For writing a GDX file with Matlab, we'll create a struct. That can have, for example, the name substitute. And now we need to add the elements. In Matlab, they are called unique element labels. So we can make the subst1 and subst2 just separated with a comma and close that thing. What type is it? We want it to be a parameter. And substitute form, just take full. Okay, the only thing missing now is the values of subst1 and subst2, and we can simply add it with a vector. I make a space here on a new line, because assigning these values can happen anywhere in the Matlab code. Usually I declare the struct at the very beginning, and then in my Matlab loop I have only this line, and here is a value x that changes with every loop, for example. But now I just want to show how to write a GDX file, and write GDX is the function. Type a name, I take GAMS optimization Matlab to GAMS, and I want to write the parameter substitute. Let's see what happens if we actually do that. This is the directory I'm in now, and we can see that there is no GAMS optimization Matlab to GAMS. But after running this script, we can see that here is a GAMS optimization Matlab to GAMS file. Now let's open it to see what we have in there. GDX files. That's the wrong directory. GAMS optimization Matlab to GAMS, and there we have the parameter substitute with the values subst1 and subst1, subst2, 1 and 2. And we need to load the data from the GDX file here in GAMS. So again, just copy this line and change the name of the GDX file. Okay, I want to load the substitute parameter, and then I can already close the GDX file. What I have to do too is to declare this parameter here. And if we now run the GAMS code, we can see that the results GDX file changed a bit, because the project duration is down to 1, just as the value in subst1. And we can also run all this from Matlab with a little loop. For example, if we choose that x goes from 2 to 5, and subst1 always has the value of x, and we can close the loop here. Here make a breakpoint so we can observe a little bit what happens. Now we wrote a GDX file, GAMS Matlab to GAMS optimization Matlab to GAMS, that should have the values 2 and 2. We can double check whether that's true. Two and 2. And if we now continue, then we should have a GDX file GAMS to Matlab, where the project duration is substituted with a 2. So let's also check that. You can see here project duration is 2 now. And continue. Now we wrote a GDX file where x is already 3. So let's check that. Now it's 3, and if we continue to run that, then we will have a new project duration of 3. And here would be all the space to later on read out GDX files and store data in arrays, and then we can plot it at the very end of the script.